Hello everyone, today we are going to talk about Born-Hooter-Ferguson method. To understand this method, we need to know that a reserving actuary often estimates the ultimate losses using several methods. Then by rationalizing the difference among the results, the actuary arrives at the final value. So the Born-Hooter-Ferguson method is a product of this practice. Is able to find a balance between the chain ladder method, which relies on developing the loss triangle, and the expected loss ratio method, which only considers losses that have fully developed. So to see how this method works, first we want to recall that under the chain ladder method, we have ultimate loss would be paid loss times ultimate factor, which implies that the estimated proportion of paid claim is LP over L ultimate, which is equal 1 over ultimate factor. So this makes 1 minus 1 over ultimate factor the estimated proportion of unpaid claim. Therefore, the unpaid claim estimate which is the reserve can be written as the ultimate loss multiplied by the estimated proportion of unpaid claim. Then the Born-Hooter-Ferguson method combines the expected loss ratio method with the version of the reserve calculation shown above. This is done by multiplying the expected loss ratio estimate of the ultimate loss by the chain ladder estimate of the proportion of unpaid claims. So in other words, this reserve calculation is done by two parts. The first part, ultimate loss, is based on the LE ratio, loss expectation ratio. The second part is based on the chain ladder method. So it's a combination. The second part, you derive the ultimate factor from chain ladder method. The first part, you derive from a loss expectation ratio method. Then your reserve is just a multiple of these two. So this is the Born-Hooter-Ferguson method. The ultimate factor is the cumulative sum of each to ultimate factor, and the expected loss ratio method would give you the ultimate loss to be this. So this Born-Hooter-Ferguson method has two components. Note that PE times ELR is not the Ferguson method estimate of the ultimate loss. To estimate ultimate loss using the Born-Hooter-Ferguson method, simply sum this all together, paid loss plus the reserve. Let's work on an example to further understand this method. You are given the following table. Accident year from 4 to 7, you have earned premium, you have expected loss ratio, and you also are given the cumulative loss payment. In the second table, assume no loss development past development year 3. Use the Born-Hooter-Ferguson method and the volume weighted average factor model estimate the reserve as of December 31st, accident year 7. So first, if we using the first table from left, you can calculate the estimated ultimate loss, which is just using the expected loss ratio for each accident year. So for example, this 3A40 would be 6,000 times 0.64, and this 4543 would be 7,700 times 0.59. The second step is estimate age to ultimate loss development factor using the chain ladder method. Note that the question tells us to use volume-weighted average model. In volume-weighted average model, basically you are having to sum up the denominator and sum up the nominator together for a factor. So factor 1 would be 255. So these three numbers divided by these three numbers. Similarly, you can calculate factor 2 and factor 3. Of course, the last factor, you only have one row to estimate, so you get 1.041. Then we can calculate age to ultimate factor. For the extended year 5, this one is just this one. First 1.041 is just this one. But for extended year 6, age 1, basically you will have to use F2 times F3. So 1.375 is really coming from 1.041 times 1.321. And similarly, 2.451 would be all these 2 times 1.783. This is the ultimate factor, is the cumulative sum of each factor summed together. This is just chain ladder method here. Okay, in previous slide we already talked about step 1 and step 2. Step 1 is just to estimate the ultimate loss using the expected loss ratio method. Step 2 is estimate age to ultimate loss development factors using the chain ladder method. Now we are on step 3, which is estimate the reserve using the formula in previous slide. So we can get extended year 5 reserve is 139. How do we get this number? Extended year 5, your ultimate ratio is 1.041 here according to this. Now the formula, remember the formula is ultimate loss times 1 minus factor. So here you first get 139 would be coming from the ultimate loss, which is 3510 times 1 minus 04. And similarly, 1095 would be 4015 times 1 minus 7. And last one is 2690, which comes from 4543 times 1 minus 2.451. This is how we calculate this. This is the final answer. This explains how you calculate that based on the step 1 and step 2. The Born-Hütter-Ferguson reserve can also be calculated as the weighted average of the chain ladder and the expected loss ratio reserve, as this formula shows. Here the reserve CL is chain ladder, RLR is loss ratio, and BF is Born-Hütter-Ferguson method. The weight here is the ultimate 1 over ultimate factor. So let's try this out with the example above. We get the following expected loss ratio reserve based on what we calculated earlier. We can calculate the reserve to be 40, 160, and 1115 and 2693. Also, we can calculate chain ladder reserve to be these 0138, 1088, 2685. Now, the weight we get is this. Weight is 1 over H2 ultimate factor, so this 0.61961 is coming from 1 over 0.41. Finally, to calculate the Born-Hütter-Ferguson reserve, we apply the weight to reserve, and we notice that the reserve is the same as what we calculated previously. So one observation we can make is the claim approach maturity. The age to ultimate factors decrease, and the weight assigned to the chain ladder reserve increase. This should make logical sense. The closer the claims are to maturity, the more data is available on those claims. Therefore, the higher weight is given to reserve calculated using the actual claim experience, that is RCL. Now look at some real examples. In this example, you are given the following age to ultimate factor, and you are also given the M premium for each accidental year and expected loss ratio. Estimate the loss reserve at the end of accident year 4 using the Born-Hütter-Ferguson method. So, since the factors are all given, we just need to apply the formula. For accident year 1, the reserve is 1150 times 0.74. The first part is just the loss expectation ratio method. It gives you the ultimate loss. So this is loss expectation loss ratio method. Then the second part is just applying the factor 1 minus 1 over ultimate factor to get the reserve. Similarly, you can calculate the reserve for second year, third year, and fourth year. Utilize the same formula. Then the final reserve would be sum of all these reserves, which is 1029. Now let's look at this second example. For a block of business, you are given Born-Hütter-Ferguson reserve to be 77,900, expected loss ratio reserve to be 78,600, earned premium to be 250,000, expected loss ratio to be 0.65, determine the chain ladder reserve. To calculate the chain ladder reserve, we need the loss paid to date and the age to ultimate factor. Using the formula, we can determine the age to ultimate factor 77,900 900 would be equal 250,000 times 0.65. That's just the loss expectation ratio method times 1 minus 1 over ultimate factor. From here, we can derive that the ultimate factor will be 1.9208. Recall that we find the loss paid to date using the expected loss ratio method. So R will be equal PE times ELR, which is the premium times expected loss ratio minus paid loss. So 78,600 would equal 250,000 times 0.65 minus LP. From there, we can get LP will be 83,900. Then the chain ladder estimate of the ultimate loss is just the 83 paid loss 83,900 times the factor, which is 1.9208. You got 161,155. Finally, the chain ladder reserve will be the ultimate loss minus the paid loss to be 77255. Now, there is an alternative way to solve this. Since we know the BF method is the weighted reserve between chain ladder method and the loss ratio reserve method. We just put in this formula and put in all the numbers in. Then you can derive that the chain ladder method will give you the 77255. So this is the alternative solution. Just utilize the second slides previously we talked about using the weighted claim reserve to be the Baum-Hutter-Ferguson reserve.